Hey guys, welcome to my video on marginal product of labor and marginal cost. I'm going to give you a rundown today of why economists usually assume that marginal costs are increasing. I guess saying economist there is a misnomer because no one else talks about marginal costs. Anyway, we're going to use a scenario today. Let's just imagine looking at a warehouse where the product that they create is just moving boxes. And the number of boxes moved is the quantity of their output. And they have a certain number of capital. We have 2 forklifts. Now, one thing we're going to assume is that in the short run, capital is fixed. The amount of capital that's in your store is all you have to work with. You can't just make another forklift appear. You can't just send a forklift home. Capital is fixed. There's 2 of them there. If we were to widen the time horizon and go long run, we could have more forklifts or fewer forklifts. But in the short run, it doesn't change. What does change is labor. You, as a manager, could schedule more workers or less workers, or call some in early or send some home early or late. Labor is variable. This is the world we're going to be looking at. So we're going to look at how much stuff we can move with these different numbers of workers. The way we're going to do that is we would just look at how much output happens with each number of workers. If there's 0 workers, we'll just assume that there are 0 boxes moved. What if 1 worker goes to work and they can use their forklift, and today they can move 1,000 boxes? There might be a situation where the second worker, the 2 of them combined, can make 2,500 boxes. And a third worker, if added, will make it so that the team moves 3,000 boxes. And the 4th worker can make it so they move 3,300 boxes. So what we have here is a production function where the more L we add, the more boxes we can move. It's so far in this range, it's strictly increasing. That's a common assumption. But we're not here just to talk about that. We're here to talk about diminishing marginal product of labor, which means first we got to figure out what marginal product of labor is. First, spoiler, you never have a marginal product when the quantity is 0 because we haven't started yet. But let's define marginal product of labor. Marginal product of labor is equal to the change in output over the change in labor. When we use the word marginal, it's always referring to if we add another one. So I'm saying with the words marginal product of labor, I'm asking what is the additional product created when we add another worker? When we added the first worker, change in quantity was 1,000 minus 0 equals 1,000. And the change in labor was 1 minus 0 equals 1. By the way, when I do changes, my personal preference is always to do the new one minus the old one. So I treat 1 as the new one and 0 as the old one. As long as you do both 1s minus both 0s, or both 0s minus both 1s, you'll be fine. But I always do new minus old so I don't get mixed up. Anyway, change in Q is 1,000. Change in L is 1. 1,000 divided by 1 is 1,000. The first worker added 1,000 units of output to our business. What about the second worker? For the second worker, the change in quantity is 2,500, there's the new number, minus the old number of 1,000 equals 1,500. And change in labor is 2 minus 1 equals 1. 1,500 divided by 1 is 1,500. The second worker in this case has a higher marginal product of labor than the first. Now, obviously, this is not my end goal, because I wanted to show you why there might be diminishing a marginal product of labor. But it's pretty common for diminishing marginal product of labor to not start right away, but to set in at some point later. In this case, with 2 forklifts, it's not hard to imagine 2 workers being better than 1, because they can both drive a forklift. And that means that they can take different sides of the warehouse or something. They'll spend less time driving all the way across, they can specialize in different areas and work more efficiently together. So adding a second worker increases production faster than adding the first. That can happen sometimes. What about the next person who comes? For our third worker, the change in quantity is 3,000 minus 2,500 is 500. Change in labor is 1. 500 divided by 1 is 500. And the third worker, 3,300 minus 3,000 is 300. Divided by 1 is 300. Now, what's the story here? Well, the gist of it is we're using all of our capital already. And so as we start adding more and more people, they might still make it so we're more productive, but each person adds less than before because their labors can't be augmented as well by the capital. Since capital is fixed, if we start throwing more and more labor at the capital, it might increase production, but not by as fast as it did at the beginning. So let me point out this range. In here, my marginal product of labor gets smaller, moving from 2 to 3. Gets smaller, moving from 3 to 4. That is what we call diminishing marginal product of labor. Because capital is fixed, whatever your business, it could be 2 forklifts, it could be a certain amount of stuff to make a pizza, it could be a certain number of computers in your building, whatever your capital equipment is, in the short run, it's fixed. And so if you throw a bunch of labor at it, at some point the additional labor won't be able to use the equipment as effectively, or at all, and the additional labor won't add as much to your production. That's where diminishing marginal product of labor comes from. Now let's get a little crazy, and let's look at labor costs. Let's say that there's a wage of $100 per worker. And if there's a wage of $100 per worker, we can calculate labor costs. When there's 0 workers, we don't pay anything in labor. When there's 1 worker, we pay 100. When there's 2 workers, we pay 200, 300, and 400. Okay, that's fine. But now we can calculate marginal cost, which is something else we're often interested in. Marginal cost is change in total cost over change in quantity. And in this simple example, the only cost I'm really measuring is labor cost, which is fine. But it's going to help us to see what's going on here. See, it's a marginal cost. We don't measure marginal stuff at 0 because it doesn't work. But what about the first worker? The first worker changed cost by $100. We had to pay them $100 to show up. But that first worker added $1,000 of product. And 100 divided by 1,000, change in total cost, divided by change in quantity, or MPL, is 0.1, is 10 cents per box moved. The second worker also changes cost by $100. Our cost goes from 100 to 200. But that worker had a marginal product of labor of 1,500. They added 1,500 to production. 100 divided by 1,500 is 0.6s, 0.066666666, whatever. I'm going to round it to 0.07. A little less than 7 cents per box moved. The third worker adds $100 to total cost and only brings 500 units of new product. 100 divided by 500 is equal to 0.2, 20 cents per box moved. The third worker adds $100 in cost, only adds $300 or 300 boxes of new stuff, which means that each box is costing about 33 cents. Now what you see here is that the marginal cost, although it went down at first, is increasing. Now later on in my next video, you're going to see these graphs where marginal cost often has this shape. This U-shaped, where it goes down and then goes up, and then it keeps going up and up and up forever. Why do we give it that shape? because that's a pretty general thing we see, where for some range, there might be some increasing marginal product of labor, but for the most part, it's going to decrease, which means that there might be some range where marginal cost is decreasing, like there, but for the most part, it's increasing, which is why the rest of the curve goes up. So when you see this big swoosh-shaped marginal cost curve, that's where it comes from. It comes from the diminishing marginal product of labor, which is a fairly general result, and its cause is that there's fixed capital. And so the more you add workers to a fixed amount of capital, the less each additional worker is going to make a difference. So I hope that's helpful to you. If not, too bad. Thanks for watching, guys, and happy econing.